Good morning, students. Hope that all of you stay safe at home. This is VJCET and I request you to utilize this time for active learning. So in this video, I want to introduce you the topic Fourier transforms from our module 4. So in the previous module, Laplace transform, we already discussed what is a transform, why do we use it, and what are its applications, and learned how to use Laplace transform and its properties. You know that the property of transforms is that they convert a function from one domain to another domain with no loss of information. Fourier transform converts a function from time domain to the frequency domain. Time domain tells us how the properties of functions changes over time, whereas the frequency domain tells us how properties changes over frequencies. Fourier analysis is the most important mathematical tool in signal processing. It represents the fundamental procedure by which a complex physical signal may be decomposed into simpler ones. Hence, Fourier transform had a wide range of application in engineering and physical science, such as digital signal processing, image processing. So, you will be familiar with such topics in your coming semesters. Also, signals and system analysis, quantum mechanics, solution of partial differential equation, boundary value problems. So, a lot of areas like that. Now, let us move on to the definition of Fourier transform. So, Fourier transform of a function f of x is given by f of x, and it is denoted by f cap omega is equal to 1 by root of 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx, and the inverse transform. Obviously, it will give the function f of x when you take the inverse. That is given by f inverse f cap omega, and what we get is f of x, which is equal to 1 by root of 2 pi integral minus infinity to infinity f cap omega e raised to I omega x d omega. So, should be careful while writing the formula of inverse transform. You can see that the integration is with respect to d omega. So, all of you just go through these two formulas and by heart it. So, we will be using this formula. We are solving problems to find the Fourier transform of certain functions. So before moving to the problem solution, I want to give you these preliminaries, which you already know, that one result as mod x less than a, which always implies mod x less than a, you know that means x less than a or minus x is also less than a. So that you will get x less than a, so minus a less than x. So that mod x less than a means x takes values between minus a and a. So when you have problems which consist of mod x less than a, you have to take the interval range as minus a less than x less than a. That is one thing to remember. Then another formula. Many of you may be familiar with that formula, which is called Euler's formula, which is given by e raised to I theta is equal to cos theta plus I sin theta. So that you get e raised to minus I theta, which is cos theta minus I sin theta. So when you add these two expressions, what you get is e raised to I theta plus e raised to minus I theta, which is equal to 2 cos theta. Hence we get cos theta is e raised to I theta plus e raised to minus I theta divided by 2. Similarly, subtracting these two expressions, again you get this another result, or the expression for sin theta, which is obtained as e raised to I theta minus e raised to minus I theta divided by 2a. So I want you to memorize these two formulas also. That is useful while we do problems. Now coming back to the other two formulas, just see these formulas are familiar to you. I already told you this formula given you in the previous chapter. That is integral e raised to ax cos bx dx is given by e raised to ax by s square plus b square into a cos bx plus b sin bx, and integral e raised to ax sin bx dx is equal to e raised to ax by s square plus b square into a sin bx minus b cos bx. So this formula will be familiar one to you. Now coming to the next two formulas I have written over here. That's integral 0 to infinity e raised to minus st cos omega t dt. So you can remember that it comes from the topic Laplace transform, where we use Laplace transform of a function f of t is integral 0 to infinity e raised to minus st f of t dt, where here it is cos omega t, so that this expression will give you Laplace transform of cos omega t. So what is Laplace transform of cos omega t? That you know it is s by s square plus omega square. Again a similar formula, integral 0 to infinity e raised to minus st sin omega t dt is equal to Laplace transform of sin omega t, which is equal to omega by s square plus omega square. So if you have any doubt, just go through the chapter Laplace transform, where we already have defined Laplace transform basic definition and the Laplace transform of certain functions, standard results. So you note down all these results, which will help you while doing the integration procedure in order to find the Fourier transform. Okay. So example 1, problem 1, find the Fourier transform of f of x which is equal to 1 for mod x less than 1 and 0 otherwise. So we already know the formula now. F cap omega is 1 by root of 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx, where f of x is the given function. So we will substitute the function over here. And when you substitute, you can see that the limit of range of 1 f of x is given mod x less than 1, which already I have explained to you earlier that it is the limit taken from minus 1 to 1. So we substitute this as f of x is from minus 1 to 1. We split up the integral as minus 1 to 1, where f of x is equal to 1. So 1 into e raised to minus I omega x dx. And in otherwise the value is 0. So only this integral value remains. Now integrating, you get 1 by root of 2 pi e raised to minus I omega x divided by minus I omega, which is being the constant within the limit minus 1 to 1. Then you take the constant term outside, that is minus 1 by I omega, as we usually do to apply. In order to apply the limit, it's better you take the constant term outside, and then you get e raised to minus I omega. Applying the limit, when x is equal to 1, it's e raised to minus I omega, minus when x is equal to minus 1, you get e raised to I omega. Applying the limit, and you just take the term like this, 1 by omega root of 2 pi, and we'll collect the term taking minus inside. You get e raised to I omega minus e raised to minus omega divided by I. So that is the answer for the Fourier transform, but anyway we will be express it in a more in a good form as e raised to I omega minus e raised to minus omega I minus I omega divided by 2I is in the form e raised to I theta minus e raised to minus I theta divided by 2I is sin theta. I have given you that in the preliminary. So we will replace e raised to I omega minus e raised to minus I omega divided by 2I as sin omega. So the final answer is f cap omega is equal to root of 2 by pi sin omega by omega. So just go through the problem. Write down the steps. First you write the formula, then apply the value of the function, integrate it, apply the limit, suitably arrange the terms so that you get the answer in a perfect way. So f cap omega for the given function f of x is equal to root of 2 pi sine omega by omega. So this root of 2 by pi comes by cancelling 2 and root 2. From 2 will cancel one root 2 and what remains is root of 2 on the numerator, root of pi in the denominator. So you have root of 2 by pi sine omega by omega. So all of you just go through the problem, just write it down on your notebook. So another problem again, f of x is equal to e raised to minus ax for x greater than 0, 0 for x less than 0. So as usual, we proceed like this. F cap omega is 1 by root of 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Here the function f of x is e raised to minus ax and it is given the range is x greater than 0. So it will limit up to infinity. That is integral from 0 to infinity. Split up the integral from 0 to infinity. Then minus infinity to 0, the value is 0. It's given as in the function. So it is, the limit becomes 0 to infinity e raised to minus ax e raised to minus I omega x dx. So we will combine those two exponential terms, that is e raised to minus of a plus I omega into x. Then you integrate it as usual. So you will get e raised to minus of a plus I omega x divided by minus of a plus I omega. Take minus outside, minus of 1 by a plus I omega outside. And applying the limit, the upper limit becomes e raised to minus infinity. And all of you know that e raised to minus infinity has the value 0. And lower limit we have e raised to 0, that's equal to 1. So simplifying, you get minus 1 by root of 2 pi a plus I omega into minus 1, which gives you the value 1 by root of 2 pi a plus I omega. Just all of you just do the problem. Try to work out yourself. So I will be uploading 2 or 3 problems more, and you'll be given some assignment questions also from this topic. So you have to answer that. So I will give you in the next video. So all of you please go through the definition of Laplace, definition of Fourier transform, and how to find the Fourier transform of certain functions given, and just any doubt you can clarify it, send messages to in my WhatsApp number. Okay, so see you later. Thank you.